Hello everyone, in this video we are going to discuss Summative Assessment 1 Model Paper. Till now, if you didn't subscribe to my channel, subscribe for more videos. In part A, we will be having description and part B, objective, right? So, in the part A, we have section 1, section 2 as well as section 3. In section 1, we will be having 7 questions. Out of 7, we need to write all the 7 questions. So, each one carry 1 marks. So, it means 7 into 1 equals to 7 marks. Okay, let us start the first question. Find the LCM of the smallest prime number and the smallest composite number. So, first, if you write the prime numbers list, the prime numbers are the numbers which have only 2 factors. So, prime numbers are 2, 3, 5, 7, 11 and so on. Then coming to the composite numbers. Composite numbers will be having more than 2 factors. So, the first composite number is 4, then 6, then 8, then 9 and so on. Now, the exact question is LCM of smallest prime number is 2 and the smallest composite number is 4. So, for 2 and 4, we need to find out the LCM. So, let us check it out. 2 can be written as 2 into 1 or just simply 2. And 4 can be written as 2 into 2. Now, in this, 2 is common. So, write that 2 into, here extra number is there, right? Write that extra number also. So, 2 into 2, 4. So, LCM of 2 and 4 is 4. Question number 2. Set B equals to X such that X is a letter in the word Telangana. Write in roster form. So, set B equals to, roster form is nothing but we need to write all the elements. So, Telangana word, in that all the alphabets we need to write. T, comma, E, comma, L, comma, A, comma, N, comma, G. Then after alphabet A, right? But alphabet A already we wrote. So don't repeat it again. Then alphabet N, already N also we wrote. So don't write again. Then coming to the last letter, alphabet A already we wrote. So if we write the roster form, we should not repeat the elements. So only the roster form consists of T-E-L-A-N-G. Question number 3. Find the zeros of 2x square minus 32. We have one quadratic polynomial. So, we need to find out the zeros of it. 2x square minus 32. Make it equals to 0. Take minus 32 to the right side. So, we get 2x square is equals to minus 32 will become plus 32. Now take this 2 also right side. Here it is multiplication. If you take another side, it becomes division. So x square is equals to 32 by 2. 2 ones are 2 16s are. So x square value is 16. X square is 16. Then what will be the x value? X is equals to plus or minus 4, because plus 4 square also 16 only, minus 4 square also 16 only. Question number 4. Is log 1000 base 10 rational number? So, log 1000 base 10, which is equals to log 1000 can be written as 10 power 3, base 10 as it is. So, in logarithms, we have one formula, that is log a power m equals to m log a. So, if you forget about this formula, if we speak the same in our words, if power is there for the main number, that power will come to the front as it is. That's it. So here 3 is the power for the main number. So that 3 will come to the front as it is. So we will get it as 3 log 10 base 10. Only the power will come to the front, remaining all will be as usual. Okay, next 3 as it is. Log 10 base 10 value is 1. So 3 into 1, 3. So here log 1000 base 10, if we solve, we got the answer 3. Answer 3. Number 3 is a rational number. Yes, log 1000 base 10 is a rational number. Question number 5. Draw a Venn diagram. So if you just read the name of the Venn diagram, we need to do immediately one rectangular box. Top right side corner universal set. 2 circles, 1 circle for set A and 1 circle for set B. This is A, this is B. Now, he gave, draw a Venn diagram such that A minus B equals to 3, 4, 5. A minus B is 3, 4, 5, right? So, only in the A, without even entering into the B, write those numbers 3, 4, 5. Finish. Next. B minus A, 1, 8, 9. So, only in set B, without entering into the A, we need to write these 1, 8, 9. Then A intersection B is 6, 7. The space where both the circles are touching with each other, this is 6, 7. So, this is the Venn diagram which we required. Coming to the question number 6. Find a quadratic polynomial if the zeros are root 5 and minus root 5. When zeros are given, to find out a quadratic polynomial, to write a quadratic polynomial, we have a formula that is k into x square minus alpha plus beta into x plus alpha beta. This k as it is into x square minus alpha and beta, right? So the first 0 or root is alpha and the second one we will take it as beta. Of course, if you take in reverse also, no problem, same answer you will get. Now alpha is root 5 and beta is minus root 5 into x as it is plus alpha into beta root 5 into minus root 5, close the bracket. Then k into x square minus plus root 5 minus root 5 cancel, so we remains with 0 x. Next, this is plus, this is minus, so plus into minus, minus. Then root 5 into root 5, this is root 5 into root 5, root 5 into root 5, it is 5, so 5 here, close the bracket. Next, k as it is into x square minus 0 into x, 0x minus 5, which is equals to k into x square. 0x is 0, so 0 is not at all necessary, so I am removing it completely. So we remains with k into x square minus 5. After solving like this step by step, if you have any denominator here, x square minus 5 by something, if it is there, means that value only you need to take in the place of k, just so that you will, the denominator will get cancelled. But in this case we don't have any denominator, so take the k value as 1 if k equals to 1. So it means in the place of this k we need to substitute 1. If we just substitute 1 and if you multiply with 1, nothing will change. So our required polynomial will be x square minus 5. Question number 7. If set A equals to 0, set B equals to odd numbers that divided by 2. Vani said that sets A and B are equal sets. Do you agree with her and why? Set A is given as 0. Set B is, he gave one statement, let us read that again. Odd numbers that divided by 2. Actually, no odd number is divisible by 2. Only even numbers are exactly divisible by 2. So there is no odd number at all which is exactly divisible by 2. So set B, we can write it as just empty set. Now if you observe this set A and set B, is set A an empty set? Obviously no, because in the set A we have an element number 0. So element 0 is present in set A, so this is not at all empty set. Set A is not empty set. Whereas coming to the set B, this is an empty set. Always empty set and a non-empty set are not at all equal to each other. So set A is not at all equals to set B. Next, coming to the section 2. In this section 2, we will be having 6 questions. Every question carries 2 marks. So 6 into 2 equals to 12 marks. Coming to the question number 8. Prove that 3 plus 5 root 2 is an irrational number. So to solve this answer, we need to write some statements in the beginning of the solution as well as at the ending of the solution. So just try to remember those sentences. On contrary, let us assume 3 plus 5 root 2 is rational. Three plus 5 root 2 equals to, we are assuming that 3 plus 5 root 2 or as the given question is a rational number. So if it is a rational number, then definitely it is going to be in the form of P by Q, right? But according to our textbook, it is following A by B alphabet. So that's why I am also writing it as A by B only. So 3 plus 5 root 2 is equals to A by B. Then the same P by Q conditions what will be there, that only we need to write. That is A comma B belongs to integers and B not equals to 0. Now, taking 3 to the right side, 5 root 2 equals to A by B plus 3. If we take another side, it will become minus 3. So, to simplify this 3, I am writing it as 3 by 1. Left side, 5 root 2 as it is equals to A into 1A minus B into 3, 3B divided by B into 1B. Now, next, taking 5 also to the right side. So we will get A minus, left side we will be having root 2, right? Okay, root 2 equals to A minus 3B divided by this 5 we are taking to the right side, right? So it will become division, 5B. That's it. Left side we have root 2, we cannot able to simplify anything. So root 2 equals to A minus 3B divided by 5B. Now, in the beginning of the sentence, we took it as A comma B both belongs to integers, right? So here we have A, here we have B, and number 3, number 5. All these are A, B, 3, 5. All are integers, right? So as A comma B comma 3 comma 5 are integers, RHS is rational. So in the place of A and B, whatever the number you substitute also, always this right side one we will get a rational number only value. But coming to the left side part, left side we have root 2, right? So but root 2 is irrational. So here clearly we can say one thing. RHS we got a rational number. LHS we got an irrational number. RHS is rational. LHS is irrational. Rational and irrational never be equal to each other. So we got definitely wrong. That only we will write the statement here. This contradiction. What contradiction? Right side rational and left side irrational. That this contradiction has arisen due to our wrong assumption. Due to our wrong assumption. So the given question, that is 3 plus 5 root 2. So 3 plus 5 root 2 is an irrational number. Question number 9. If set A equals to 1, 3, 5, 7 and set B equals to 1, 2, 3, 4, 5, then find the values of A minus B and B minus A. So first let us find out a minus b. So to find out a minus b, what we need to do first? From the set A, we need to remove the elements which are there in B also. Here 1 is there in set B also, so I removed. Then 3 is there in set B also, so I removed. 5 is there in set B also, so I removed. That's it. Okay, now from set A, pick the elements which are remaining still. So only 7 is remaining, right? Write that 7 here. So a minus b equals to 7. Then finding b minus a. Now to find out b minus a, we need to select the set B now. Okay, 1 we need to remove, 3 we need to remove, 5 we need to remove, because 1, 3, 5 are there in set A also. Now after removing those, still what we remains with in set B only, that is 2 and 4. So b minus a will be 2, 4. Coming to the question number 10. Give possible expression for the area of a rectangle whose breadth is x units and its length is 3 units more than its breadth. So let the breadth or width, both are same, that is given in the question itself, x units, and length will be, what he said, 3 units more, so x plus 3. Then he is asking to find out one expression for area of the rectangle. So what is the formula for area of a rectangle? Area of a rectangle is equals to length into breadth. So here length we have as x plus 3 into breadth we have as x. So if you multiply these two, x into x, x square plus 3 into x, 3x. So the expression for area of rectangle is x square plus 3x unit square. Don't forget this. Coming to the question number 11. Find the value of x if 2 log 3 plus 4 log 2 minus 2 log 12 equals to log x. So before going to solve, let us discuss the formulas which involved into this. Log a power m equals to m log a. Log ab equals to log a plus log b. Log a by b equals to log a minus log b. Now let us make all these formulas simple. If the power is for the main number, it will go to the front as it is. In reverse, if the number is front, it will go as a power. Multiplication is there means it will become plus. If plus is there means it becomes multiplication. Division is there means it becomes minus. Minus is there means it becomes division. That's it. So now let us check one by one how to apply these formulas in the question. Okay, the question which he gave is 2 log 3 plus 4 log 2 minus 2 log 12. 2 log 12 equals to log x. Okay, now we don't have any work with the right side part, so until the last step we will write the right side part as it is. Now 2 is the front number, it will go as the power. 4 is the front number, it will go as the power. Here again 2 is the front number, it will go as the power. So we will get log 3 power 2 plus log 2 power 4 minus log 12 power 2 equals to log x. Log 3 power 2 9 plus log 2 power 4 16 minus log 12 square 144 equals to log x. Now if we observe the first term and second term clearly, log 9 plus log 16. In logarithm, if a plus is there means that will become what? Multiplication. So log 9 and 16, both the numbers we need to do multiplication, minus log 144 as it is equals to log x. log 9 times 16 144 minus log 144 as it is equals to 0. Now here log 144 minus log 144 will become 0, which is equals to log x. So how we can convert this 0 to? So 0 can also be written as log 1, which is equals to log x, because right side we have logarithm, so definitely left side also should be there. So that is the reason I replaced 0 with log 1. Now if we compare, so 1 is equals to x, or else x is equals to 1. Coming to the next 12th question. If the roots of the polynomial 9x square minus 5kx minus 16 are additive inverse to each other, then find the k value. Two roots we are taking as alpha and beta. Okay. Alpha I am keeping as alpha only. Then what about beta? He said clearly that if the roots of the polynomials are additive inverse to each other, it means symbol we need to change, right? So alpha is alpha only, means then beta will become minus alpha. Now these two I am adding, that is alpha plus beta. We have a formula that is minus b by a. Alpha is alpha only, but beta is minus alpha, is equals to minus symbol as it is b. B value, what is b value? Here x coefficient is b value, that is minus 5k, divided by a value x square coefficient, that is 9. So left side alpha minus alpha is 0 only, is equals to minus of minus 5k plus 5k divided by 9. So 9 if we take to this side, otherwise just simply we can say 0 equals to something, means definitely k value should be 0 only, there is no other option. So if k value equals to 0, then only that is equals to 0. Otherwise take this 9 this side, then after do multiplication division again, as usual you will get the same answer, no problem at all. Question number 13. If 2 log of x minus y equals to 2 log 3 plus log x plus log y, then show that x square plus y square equals to 11xy. So the given statement is 2 log of x minus y equals to 2 log 3 plus log x plus log y. Here all before the logarithms numbers are there, so that all will go as a power. This will go as a power. Here nothing is there, here nothing is there, so no problem. So now what we will get then? Log of x minus y whole square is equals to log 3 square plus log x plus log y. Left side we cannot simplify, so I am writing as it is. Log of x minus y whole square is equals to log 3 square can be written as 9 plus log x plus log y. Still again left side we can do nothing, so I am writing as it is. Log of x minus y whole square equals to log 9 plus log x plus log y. In logarithms plus b will become multiplication. So log 9 plus log x plus log y can be written as 9 into x into y. So log 9xy. Now left side we have one logarithm, right side also we have one logarithm. So just we will remove the logarithms and write the remaining part. That is x minus y whole square is equals to 9xy. This x minus y whole square is in the form of a minus b whole square. If we expand it, x square plus y square minus 2xy equals to 9xy. Take minus 2xy to the right side, then we will get x square plus y square equals to 9xy. Minus 2xy will become plus 2xy. So finally x square plus y square equals to 9xy plus 2xy. It is 11xy. Now in section 3 we will be having 4 questions. For every question we will be having internal choice. 14th A or B. 15th question A or B, 16th question A or B, 17th question also same A or B. So out of A or B, any one we need to write. So in this, every question carries 4 marks. So 4 into 4 is equals to 16 marks. Okay, coming to the question number 14A. Find the LCM as well as HCF of any three two-digit composite numbers only in prime factorization method. So first, let us pick the two-digit numbers. 14, 16, 18. Three numbers I have, and those three numbers are two-digit numbers only, and all those three are composite numbers only. Now he is asking to find those values with the prime factorization method only, right? So let us find it out. 14 can be written as 2 into 7. 16 can be written as 2 into 2 into 2 into 2. 18 can be written as 2 into 3 into 3. Now, how to, if you are unable to do like this directly, means just go like this again. 2 8s are, 2 4s are, 2 2s are, 2 1s. So 16 can be written as 2 into 2 into 2 into 2. If you know directly, means you can write directly, no problem. Okay, now select the numbers which are common in all the three. That's it. Except 2, nothing is common. So that common number we need to keep in HCF. HCF is 2. If more than one number is common, means you can do multiplication still. For example, if 3 is also common, 2 into 3. If 5 is common, 2 into 5, like that. Then coming to the LCM part. Now first write the number which is common into whatever the numbers which are extra, write all those extra numbers. Here 7 is extra, so write that. Into, here 2 is extra, write that. Into, again 2 is extra, write that. Into, again 2 is extra, write that. Into, here 3 is extra, 3 is extra. So 3 into 3. So now if you multiply all these numbers, then we will get the LCM. So I am coming from the back side onwards. 3 into 3, 9. I'm sorry. 9 2s are 18. 18 2s are 36. 36 2s are 72. 72 into 7. 504. 504 into 2. 1008. So LCM of 14, 16, 18 is 1008, whereas HCF is 2. Next, 14th question, B1. If the two zeros of x power 4 minus x cube minus 7x square plus x plus 6 are 1 and minus 1, then find the remaining zeros. For the polynomial, first he gave two zeros. One is 1 and one is minus 1, right? So 1 I am taking as alpha and minus 1 I am taking as beta. So we have alpha and beta values. So by using the formula, which formula? Creating or writing a polynomial when two zeros are given, that is k into x square minus alpha plus beta into x plus alpha beta. By using this formula, we need to find out the polynomial. Okay, let us do it now. K as it is into x square minus alpha is 1 and beta is minus 1 into x plus alpha is 1 into beta is minus 1. K into x square minus 1 minus 1 is 0. So 0x plus into minus minus 1 1s are 1, which is equals to k into x square. This 0 term completely I am removing because it's no use. So minus 1 as it is. K we can remove it. So we required polynomial is x square minus 1. Now this, the given number x power 4 minus x cube minus 7x square plus x plus 6 and the required polynomial x square minus 1, both we need to do long division. So x square minus 1 x power 4 minus x cube minus 7x square plus x plus 6 plus x plus 6. Okay, come on, let us do this division now. X square should be multiplied by which number? We will get x power 4. Obviously, it is x square. X square, if we multiply with x square, we will get x power 4. So, x square into x square is x power 4. Next, x square we multiplied with x square means minus 1 also we need to multiply with x square only. Minus 1 into x square minus x square minus x square. Power 4 term I wrote it under the power 4 only. Power 2 term I wrote it under the 2 term only. If you write like that only, you won't do any mistakes. Okay, next we need to do subtraction. So plus becomes minus, minus become plus. These two will get cancelled. Then drop minus x cube as it is, minus x cube. Then minus 7x square plus x square minus 6x square, dropping remaining plus x and plus 6. If you drop one by one, if you drop all at a time, it's up to you, no worries at all in that. Next again, x square should be multiplied by which number? So we will get minus x cube, x square into minus x. X square into minus x is minus x cube. Then minus 1 into minus x plus x. Again we are doing subtraction, so minus becomes plus, plus becomes minus. Minus x cube plus x cube cancel, dropping minus 6x square as it is, plus x minus x cancel, plus 6 as it is. Next, x square should be multiplied by which number? So we will get minus 6x square, that is minus 6. X square into minus 6 minus 6x square, minus 1 into minus 6 plus 6. If you do subtraction, minus become plus, plus become minus. This one cancel, this one cancel. So the remainder is 0. So now pick the polynomial which we got in the quotient, that is x square minus x minus 6. X square minus x minus 6. Now by splitting the middle term into two terms, we need to find out two more zeros of it. X square as it is minus x can be written as minus 3x plus 2x minus 6 as it is. Now from the first and second terms we can take out x common, so remains with x plus 3, then plus 2 common, remains with x minus 3. X minus 3 two times, so write it once into x plus 2. So here x is equals to minus 3 is there, so plus 3, plus 2 is there, minus 2. Here minus 3, so plus 3, here plus 2, minus 2. So the remaining two zeros are plus 3 and minus 2. Coming to the question number 15a. If set A equals to x such that x is equals to 2 power n, n belongs to natural numbers and n less than or equals to 5. So first let us write the roster form for set A. What is saying? X such that x is equals to 2 power n, right? So x is equals to 2 power n. And the condition he gave, n belongs to natural numbers, n less than or equal to 5, right? So 1 by 1 natural number, let us substitute then. X is equals to 2 power 1, then x is equals to 2 power 2, x is equals to 2 power 3, x is equals to 2 power 4, x is equals to 2 power 5. 2 power 1 2, 2 power 2 4, 2 power 3 8, 2 power 4 16, 2 power 5 32. 2 4 8 16 32. 2 4 8 16 32. He said clearly in the question itself n less than or equal to 5, so I stopped till the power 5 only. Next, set B he gave it as in reverse, that is n square. X is equals to n square. And what is the condition he gave? Same, n belongs to natural numbers only, n less than or equals to 7. Okay. So first 1 square, then after 2 square, then 3 square, then 4 square, 5 square, 4 square, 5 square, 6 square and 7 square. So simply squares we need to write till 7, right? Let us write it then. Set B equals to 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36, 7 square 49. So now we have set A as well as set B. Let us check it out what he is asking exactly in the question. Then I hope he is asking two questions. Yes. So draw Venn diagrams for A minus B and B minus A. Set A we have, set B we have, so we need to draw the diagrams. Come on, let us do it then. First a rectangular box, two circles inside of it, one circle for set A and one circle for set B, top right corner universal set. Now always to draw the Venn diagrams follow like this only, it will be better. Now in set A and set B, which elements are common? Check it once. 4 is common, 16 is common. So 4 and 16 you need to write it in this middle place, 4 and 16. Now 4 completed, 16 completed from set A, remaining are 2, 8 and 32, right? Write those in set A, 2, 8, 32. Then in set B we will be having remains with 1, 9, 25, 36, 49, right? Write all those in second circle. 1, 9, 25, 36, 49. Finish. This is all about drawing the Venn diagram. Now two questions is asking, right? So one more also same like this only I am keeping ready. This I will go for A minus B and this I will do for B minus A. Same again, two circles, one for set A and one for set B and universal set. Here 4 and 16 as it is, 2, 8, 32, 1, 9, 25, 36 and 49. Okay. In the first one, he is asking A minus B, right? So when if he is asking A minus B, just simply you need to do this only shading. You should not go into the set B. Finish. Next, the second one he is asking B minus A, right? So only set B. Do not enter into the set A at all. Finish. This is the Venn diagram for A minus B and B minus A. Next, draw the graph of x square minus 2x minus 3. So to draw the graph of it, first take the given quadratic polynomial as y. Y equals to x square minus 2x minus 3. Am I correct? Yes. Now you need to make one box. One for x, second row for y and third row for x comma y. This is quadratic polynomial graph. How many more values you will take to draw the graph, that much accurate figure you will get. But whereas coming to the pair of linear equations in two variables graph, in that just 2 points are enough because that is a straight line. So straight line doesn't have any problem, but coming to the polynomial which is a curve shaped or else parabola I can say. So in this, how many more points you will take to draw the graph, that much perfect figure you will get always. First in the place of x I'll substitute 0, then 1, then 2, then 3, then 4. I will minus 1, minus 2, minus 3 and minus 4 I'll substitute. Of course, these all values may be necessary to us or may not be necessary to us. That is the secondary thing. But it's our first responsibility to find out all the values. That's it. Because sometimes when we are substituting, we will get a very big number, which even it is not at all possible to draw on that graph paper which is present. So sometimes the values may be useful or may not be useful. That we will think later. First, let us substitute now. Y equals to x square minus 2x minus 3. Y equals to x square minus 2x minus 3. Now first thing I am substituting 0. 0 square minus 2 into 0 minus 3. Zeros are not at all necessary, so simply we can remove. So minus 3. Next, I will substitute 1. 1 square minus 2 into 1 minus 3. 1 square is 1, minus 2 ones are 2, minus 3. 1 minus 2 minus 1 minus 3, minus 1 minus 3 minus 4. Then for the same polynomial I am substituting 2. 2 square minus 2 into 2 minus 3. 2 square 4 minus 2 to the 4 minus 3. 4 cancels, so remains with the 3. Next I am substituting 3. So it will be 3 square minus 2 into 3 minus 3. 3 square 9 minus 2 3 is 6, 9. 9 minus 6 3 minus 3 as it is, so it will become 0. Now for the same polynomial I am going to substitute 4. So that will be 4 square minus 2 into 4, sorry not plus, minus 3. 4 square 16 minus 2 4s are 8 minus 3. 16 minus 8, 8 minus 3, 8 minus 3, 5. Let us write these all numbers in the box. When I substituted 0, I got minus 3. So 0 means minus 3. When I substituted 1, I got minus 4. So 1 is minus 4. When I substituted 2, I got 3. So 3 here. When I substituted 3, I got 0. So 0 here. When I substituted 4, I got 5. So that 5 here. Then these points will become 0 comma minus 3, 1 comma minus 4. This will be 2 comma 3, and this will be 3 comma 0. This will be 4 comma 5. Now let us substitute one by one negative numbers now. The polynomial is y equals to x square minus 2x minus 3. Now first substituting minus 1 equals to minus 1 square minus 2 into minus 1 minus 3. Minus 1 square is 1, minus into minus plus, 2 ones are 2, minus 3. So this will be 1 plus 2, 3, 3 minus 3, 0. Now I am substituting minus 2. Minus 2 whole square minus 2 into minus 2 minus 3. Minus 2 whole square 4. Minus 2 into minus 2 plus 4 minus 3. 4 plus 4 8. 8 minus 3 5. Next substituting minus 3. Minus 3 whole square minus 2 into minus 3 minus 3. Minus 3 whole square 9 plus 2 3s are 6 minus 3. 9 plus 6 15 minus 3, that is 12. Now substituting minus 4. Minus 4 whole square minus 2 into minus 4 minus 3. Minus 4 square is 16 plus 2 4s are 8 minus 3. 16 plus 8 24. 24 minus 3 21. Let us write these in the box now. When I substituted minus 1 0. So minus 1 is 0. Next when I substituted minus 2, I got 5. So minus 1 is 5. When I substituted minus 2, oh my god, something wrong, huh? No, correct one. Okay. Minus 1 only 0, right? Okay. Minus 2 is 5. Oh, sorry. Here I wrote, that's why I'm getting confused. Minus 2 is minus 5. Oh, sorry, only 5. Minus 2 is 5. Next, coming to the minus 3. Minus 3 is 12. Then last, when I substituted minus 4 is 21. Now see here, when we do substituting minus 4, we got the answer 21. Of course, 21 is not at all possible to draw on the graph because comparing to the remaining number 0, 3, 5, those are very small numbers and 21 is very big. So the number won't be there obviously in the graph paper. Of course, it is there or not there, we will discuss later. So no worries with that, just I'm keeping like that only. Now the points will become minus 1 comma 0, minus 2 comma 5, minus 3 comma 12, minus 4 comma 21. Now let us represent all these points on the graph paper. First one I am starting from 0 onwards, 0 comma minus 3. This will be 0 comma minus 3. Next 1 comma minus 4, 1 comma minus 4. Then 2 comma 3, 2 comma 3. This is 2 comma 3. Then 3 comma 0. This is 3 comma 0. Then 4 comma 5. This will be the 4 comma 5. Oh, sorry, here 2 comma minus 3, right? This is, that's why I'm thinking the graph is not coming properly. 2 comma minus 3, this is 2 comma minus 3. So this point won't be there, no worries with this. 2 comma minus 3, this is 2 comma minus 3, correct. Next, coming to the negatives, minus 1 comma 0, this is minus 1 comma 0, and minus 2 comma 5, this is minus 2 comma 5, and minus 3 comma 12, minus 3 comma 12, and minus 4 comma 21. Of course that is not there, so I'm not worrying about that one. Now let us join all these points just with the hand, no use of scale. That's it. So this is the graph and we need to write the scale On x-axis 1 centimeter equal to 1 unit. On y-axis 1 centimeter equals to 1 unit. Now if you observe this graph is touching the x-axis at here 3 and here at -1. So 3 and -1 are zeros of the given polynomial. Next, coming to the question number 16, A1. If set A is a set of factors of 36, so set A equals to, he is asking factors of 36. 36 will come in which tables? 1 table, 2 table, 3 table, 4 table, then 6 table, then 9 table, then 12 table, then 18 table, then 36 table. Next, set B is a set of first 6 multiples of 6. Then set B equals to 6 multiples. So 6 table, 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, 6 6 are 36. Because he is asking just a 6 multiples only. Then he is asking us to find out A union B as well as A intersection B. So let us find it out. First, A union B. A union B is nothing but everything we need to write from set A as well as set B, right? So first let me finish all the elements from set A. 1, 2, 3, 4, 6, 9, 12, 18, 36. Okay, next. Here 6 is there, but already I 6 wrote. 12 already I wrote. 18 already we wrote. 24 we did not write, so write it now 24. Then 30 we did not write, so write 30. 36 completed already. So this is all about A union B. Then he is asking also to find out A intersection B. So let us find it out also. A intersection B. So A intersection B is nothing but the elements which are common in both the sets. 6 is common, 12 is common, 18 is common, 36 is common. So 6 comma 12 comma 18 comma 36 will be the set A intersection B. Next, B. Show that the square of any positive integer is of the form 4p or 4p plus 1. For this also a small sentence will be there in the beginning. Let A be any positive integer and B equals to, here 4p plus 1, here 4p is there, right? So in that the number 4 is nothing but our b value, that is nothing but our divisor. So if divisor is 4, then what are the possible reminders we will be having? Always the remainder will start from 0 onwards and it should be compulsory less than the divisor. So if divisor is 4 means the reminders will be 0, 1, 2, 3. That's it. 4 won't come. Now let us substitute these numbers in our formula, that is Euclid's division. A equals to BQ plus R. So A equals to, B value is 4, right? So substituting 4, Q as it is plus, first remainder I am taking 0. So A equals to 4Q plus 0, that's nothing but 4Q. Now according to the question, he is speaking clearly that show that square of any number. So let us do squaring on both the sides here. Squaring on both the sides. So what it will become then? A square equals to 4q whole square. A square as it is 4q whole square, 16q square. We want everything in the form of either 4 into something or 4 into something plus, right? So that is the reason I am taking 4 common from this. So if we take out 4 common, then we remains with 4q. So now we can say that it is in the form of 4p, where p equals to what is there in the bracket, you write that one, 4q square. Now first reminder completed, right? Let us take the second reminder. What is the second reminder? That is 1. So A equals to 4q plus 1. Here also same again, squaring on both the sides. So we will get A square equals to 4q plus 1 whole square. Now again 4q plus 1 whole square is in the form of a plus b whole square. So if we expand it, 4q whole square plus 1 square plus 2 into 4q into 1. A plus b whole square equals to a square plus b square plus 2ab. 4q whole square 16q square plus 1 square 1 plus 2 into 4q into 1 8q. In this 16q square and 8q I will write together and 1 I will write separately. So 16q square plus 8q plus 1. Now we need to take out 4 only common, right? So I will take out this 4 common from these first two terms. So we remains with 4q square plus 2q plus 1 as it is. Now we can say that this is in the form of 4p plus 1 where p equals to, in the bracket what is the, write that one, 4q square plus 2q. 0 remainder completed, 1 remainder completed, then we need to go with the 2 remainder, right? So let us check. A equals to 4q plus 2. Again same process, squaring on both the sides. So we get a square equals to 4q plus 2 whole square. Here a square as it is, 4q plus 2 whole square is in the form of a plus b whole square. So if we expand it, 4q whole square plus 2 square plus 2 into 4q into 2, which is equals to 4q whole square 16q square plus 2 square 4 plus 2 into 4 8 8 into 2 16q. Now again from these all three we can take out 4 common, so I am taking 4 common, then we remains with 4q square plus 1 plus 4q. Now it is in the form of 4p where p equals to, what is there in the bracket, 4q square plus 1 plus 4q. 0 1 2 remainders completed. Now coming to the remainder 3. A equals to 4q plus 3, squaring on both the sides. A square equals to 4q plus 3 whole square. Again 4q plus 3 whole square is in the form of a plus b whole square. So if we expand it, we will get 4q whole square plus 3 square plus 2 into 4q into 3. That is equals to 4q whole square 16q square plus 3 square is 9 plus 2 4 is 8, 8 is a 24q. Now I am writing this 16q square as it is plus 24q as it is and 9 at the last. Again 16q square as it is plus 24q as it is plus 9 I am writing it as 8 plus 1. From these three terms again we can take out 4 common. So if we take out 4 common, we remains with 4 4s are 16, 4 6 are 24, 4 2s are 8, then plus 1 as it is. Again it is also in the form of 4p plus 1 where p is equals to this one. Coming to the question number 17a. We have a Venn diagram and is asking us to verify n of a union b equals to n of a plus n of b minus n of a intersection b. First of all, n of a union b is nothing but total elements we need to do. It means in this total, how many elements are there? 1 2 3 4 5 6 7 8 9 elements are there. So n of a union b is 9. That is equals to n of a, only set a, how many are there? Count it. Now this total circle is set a, right? So how many are there total? This is 1 2 3 4 5 6 are there. So n of a is 6 plus n of b. Now in set b, how many circles, how many elements we have? Let us check all those. 1 2 3 4 5 elements are there in set b minus n of a intersection b. It means how many elements are there common in both, that is 5 and 9. So 2 elements are there common. Now let us do this simplification of it. 9 equals to 6 plus 5 11 minus 2 as it is. 9 equals to 11 minus 2 9. So 9 equals to 9. Last question. Verify 1 comma minus 1 comma minus 3 are zeros of x cube plus 3x square minus x minus 3 and verify the relationship between zeros and coefficients. So first let us take the given cubic polynomial x cube plus 3x square minus x minus 3. Let us substitute these numbers one by one in the place of x. First I am taking plus 1. Okay, I'll take plus 1 and I'll substitute here. So we will get 1 cube plus 3 into 1 square minus 1 minus 3. 1 cube is 1 plus 3 into 1 square is 1 minus 1 minus 3. So 1 as it is, plus 3 ones are 3 minus 1 minus 3. Plus 1 minus 1 cancel, plus 3 minus 3 cancel. So the answer is 0. So it means plus 1 is 0. Confirmed. Next, substituting minus 1. So we will get minus 1 whole cube plus 3 into minus 1 whole square minus of minus 1 minus 3. Minus 1 whole cube minus 1 plus 3 into minus 1 whole square plus 1 minus into minus 1 plus 1 minus 3 as it is. Minus 1 plus 3 ones are 3 plus 1 minus 3. Minus 1 plus 1 cancel, plus 3 minus 3 cancel, so remains with 0. So minus 1 is also 0 of the polynomial. Then substituting minus 3. Minus 3 whole cube plus 3 into minus 3 whole square minus of minus 3 minus 3. Minus 3 whole cube minus 27 plus 3 into minus 3 whole square 9 minus into minus 3 plus 3 minus 3 minus 27 plus 3 9 is 27 plus 3 minus 3 minus 27 plus 27 cancel, plus 3 minus 3 cancel, so remains with 0. It means plus 1 minus 1 minus 3 all are zeros only. So one number I will take it as alpha, one number I will take it as beta, and one I will take it as gamma. So alpha equals to plus 1, beta equals to minus 1, and gamma equals to minus 3. Plus 1, minus 1, minus 3. By using this, we need to find out sum of the zeros, that is alpha plus beta plus gamma value. Alpha is 1, beta is minus 1, gamma is minus 3. Plus 1 minus 1 cancel, so remains with minus 3. Sum of the zeros, that is alpha plus beta plus gamma value, we got as minus 3. Next, finding 2 at a time, that is alpha beta plus beta gamma plus gamma alpha. Alpha into beta 1 into minus 1 plus beta into gamma minus 1 into minus 3 plus gamma into alpha minus 3 into 1. So if we simplify this, 1 into minus 1 minus 1 minus 1 into minus 3 plus 3 minus 3 into 1 minus 3 minus 3 plus 3 cancels, so remains with minus 1. Next, product of the zeros, that is alpha into beta into gamma value. Alpha is 1, beta is minus 1, gamma is minus 3. 1 into minus 1 minus 1 minus 1 into minus 3 plus 3. So alpha plus beta plus gamma value, we got it as minus 3. Alpha beta plus beta gamma plus gamma alpha, we got it as minus 1. And alpha into beta into gamma value, we got it as 3. Now these all we did without the help of a formula. Now same 3 we need to find out with the help of formula. That is sum of the zeros of a cubic polynomial formula and sum of the zeros taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha formula. Then finally alpha into beta into gamma formula. So let us check it out now. Alpha plus beta plus gamma formula, alpha beta plus beta gamma plus gamma alpha formula, then finally alpha beta gamma formula. Alpha plus beta plus gamma minus b by a, alpha beta plus beta gamma plus gamma alpha c by a, alpha into beta into gamma minus d by a. So let us substitute now. First, here minus symbol as it is. What is b then? Here b is nothing but x square coefficient, that is 3. So write here 3 divided by a is nothing but x cube coefficient. Here before x cube nothing is there, so it means 1. Here 1 minus 3 by 1 is minus 3. So here also we got minus 3 only. Without formula, with formula also we got minus 3 only. Next, alpha beta plus beta gamma plus gamma alpha, c by a. C is x coefficient. Here before x nothing is there, so it means minus 1. C is minus 1 divided by, then coming to the A already we know 1. So minus 1 divided by 1, minus 1 only. Next, here also we got minus 1, here also minus 1. Then finally alpha into beta into gamma, that is minus d by a, right? So minus d, nothing but constant. Here constant is minus 3. Already we have 3, minus symbol. So minus of minus 3 divided by a is 1. Minus of minus 3 plus 3. So here also we got plus 3, here also we got plus 3. This is the verification of the zeros with the coefficients. If you like my explanation, please subscribe to my channel. Thank you.